find the derivative of f of x equals radical x. We actually did this in one of the example problems from a previous lesson, but let's do it again formally. So we have f prime of x equals f of x plus h minus f of x. I always write down my definition. See, again, I forgot my limit. You know, it's unbelievable. I never remember to write down my limit. I mean, I remember to take the limit, but I just never remember to write it down. Limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so again, I'm not going to write the limit over and over again, so I'm just going to go ahead and work with the function. So radical x, so f of x plus h is radical x plus h minus radical x, that's the f of x, divided by h. I have to manipulate it, so I'm going to go ahead and multiply by the conjugate of the numerator. So it's going to be radical x plus h plus radical x over radical x plus h plus radical x. I end up with x plus h minus x all over h times radical x plus h plus radical x. That and that go away, leaving me just h on top. H and h cancel, and I'm left with 1 over radical x plus h plus radical x. Now I take the limit. The limit as h goes to 0 of 1 over radical x plus h plus radical x. H goes to 0. This turns to 0. I'm left with 1 over radical x plus radical x. I get 1 over 2 radical x. That is my f prime. So f prime of x equals 1 over 2 radical x. All right. So, adjust my paper here. So I've got f prime of x equals 1 over 2 radical x. Y prime of x, same thing, different notation, 1 over 2 radical x. And the last notation, dy over dx equals 1 over 2 radical x. Okay, so now I'm going to ask the question, what is dy dx at x equals 3? Well, very simple. Dy dx at x equals 3 is equal to, just plug in 3, 1 over 2 rad 3. Okay, what is the f of 3? Well, f, we said that f of x, the original function, is just radical x. So f of 3 is equal to radical 3. So the tangent line to the graph for x equals 3 touches the graph at the point x f of x, which is equal to 3, that's our x value, f of that, which is radical 3. And has a slope of 1 over 2 rad 3. So notice how I did that. The curve itself, there is an x value. That x value is going to give me a y value. So the point is going to be your xy, or your x f of x. The derivative at that point is the slope of the line. So now you have a slope and you have a point that it passes through. You can find the equation of that line. The equation of the tangent line is, well, we know that it's y minus y1 equals m times x minus x1. So here it's going to be y minus y1 is rad 3 equals the slope, which is 1 over 2 rad 3 times x minus 3. That's it. Here we go. At the point, so the red is the graph, the black is the tangent line to the graph at x equals 3. So at the value x equals 3, I go up here. So this point right here, this is my 3 rad 3. This is y equals radical x. Okay, this line, the equation of this line, we just found it. This is y minus rad 3 equals 1 over 2 rad 3 times x minus 3. Y minus y1 equals m times x minus x1. This point is easy to find. You just plug in the x value and you get the y value. That's going to be the 3 in the rad 3. The slope, that's from the derivative. F of x equals radical x. F prime of x, 1 over 2 radical x. It's that simple. Hope that made sense. So let me write out everything here. So f of 3 equals 3. So the tangent line touches 3 radical 3. Now f prime at 3 equals 1 over 2 rad 3. So slope of this tangent line is 1 over 2 rad 3. Now let's go ahead and take a look at the graph and its derivative as functions of x. Here is the function y equals radical x. This is the derivative. It is y prime. It is equal to 1 over 2 radical x. The graph, the original graph, the derivative, the black, describes how the slope changes as x gets bigger and bigger. Notice the slope is almost straight up infinite. It's positive, 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 positive. Always a positive slope along the curve, but the positive slope is decreasing. It's the slope line, the tangent line is actually dropping down, getting close to a slope of 0. That's what this describes. High positive, 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 but the slope is getting closer to 0. That's it. So if I want to know what the slope of the tangent line at that point is, it's going to be that number right there. That's what that tells me. Okay, thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.